as you can see here, we've got two Venn diagrams. This one goes ahead and tells us, hey, look, A and B are inclusive events. We can see they overlap. Down here, events C and D are disjoint events. And hopefully, as we look at that, when we think about the word disjoint, we think of mutually exclusive. Disjoint is kind of a different way of saying, hey, look, these events are mutually exclusive. They aren't overlapping at all. They don't share any outcomes. So let's think about each of these questions. So probability of getting A, clearly it's referring to the top Venn diagram over there. Well, the probability of getting A, the A bubble, isn't just that 0.08. We have to combine it with the 0.7. That means the probability of getting A is 0.78. Next, the probability of A and B. Well, we don't need any fancy formulas for that either. Probability of A and B, where they overlap, is A and B. That's 0.7. So it's just labeled there. But then we get to the probability of A or B. So that word or we might want to try out a formula for, but we're also going to make sense of it over here in the Venn diagram. A or B, we know that's the union. That was even marked for us right there. Look at that. The union of that means it's everything. It's everything in A, everything in B. It's combined together. And so there's two ways we can do this. We can just simply add these numbers up because we know we're going to add it all up there. And that would give us a 0.85. But remember our formula when we have or for mutually exclusive or inclusive events. We're going to take the probability of getting A, which is 0.78. We're going to add it to the probability of getting B, which is 0.77. And we're going to subtract away the overlap, which is 0.7. Probability of A, the whole A bubble, plus probability of B, the whole B bubble, minus the overlap. 0.78 plus 0.77 minus 0.7, we get 0.85. So either way makes sense. Next one, the probability of A complement. Probability of A complement, that's everything not in our A bubble. That includes both of these probabilities out here, so that would mean the probability would be 0.22 when we add those together. Next, the probability of A and the complement of B. A and the complement, that means we have an overlap. That word and means we need to find what is true about both of these things. A and, so here's A, those two values. The complement of B is everything outside of B. Where do we have overlap? It's that 0.08. That is the probability that we get A and not B. All right. Moving on to this next set, the probability of getting C. Well, I'll clear C, we're referring to this event down here, part of our disjoint set. Probability of getting C, well, look at the C bubble, it's 0.08. It's that simple. Next, the probability of getting C and D. C and D. We want both C and D to be true. We want an overlap. We want to find the probability of getting both of these things. Well, they never overlap. There's never a point they overlap. There's a 0%, 0, there's no chance of both of these things happening at the same time. The union, probably of getting C or D, well that means, hey, this or this, well we can add them together, we can see that's going to be a 0.3, or because we're using or, we can think of it as our formula. The probability of C plus the probability of D minus the overlap. There is no overlap. And 0.08 plus 0.22 minus nothing gives us 0.3. The formula still works. Next, probability of the complement of C. Well, everything outside of C is these two values. So we can definitely add those up to get 0.92. And finally, the probability of not C and not D, and both of these things have to be true. Not C is these two values. Not D is these two values up here. Where do they overlap? That word and be 0.7. Okay, so it's kind of tying in a lot of things throughout this that we've talked about probability. We've related back to Venn diagrams. We've talked about and, we've talked about or, we've talked about inclusive, mutually exclusive events. This right here kind of ties everything in. So hopefully this feels good. Hopefully this makes sense.